Why do we care? I told you that applied mathematicians and physicists know three things. They know about integration by parts, which at the moment I'm not using. Why am I using integration by parts? I'm taking these integrals to plus minus of infinity, and I'm quietly assuming that whatever I care about is zero at infinity, so I don't have to care about ends of integration. And particularly, what am I going to integrate? I know how to integrate only one thing. It's a Gaussian. So let's define tilde of k, Fourier transform over Gaussian. And now I will put the 2 pi where it belongs. It's a square root, because if I take e to the minus x squared over 2 and divide this by square root of 2, then I know that this integral equals 1. So that's a good way of writing 1. But if there is some constant here, it's called covariance in the probabilistic parlance, or anytime you analyze your data. Then I have to, by scaling argument, this scales like square root of x. Like square root of this goes like that. This is still a unit integral. But now I call it the Fourier transform because I add minus kx. So now I have an integral over something that's quadratic, something that's linear. That's still something we can do. So I take half in front, delta. There's a minus minus, so let me put this here. 2k. 2 canceling this. And now, if I add delta k squared, I realize that this is, in a profound way, a square of something. But I have to, I added it as a minus sign, so I have to subtract it as well. Now, this is a function of x, so this is a constant, so that goes out. And this one, I realize I can write, I've completed the square. So I can change the variable in here and integrate over it. And what I get is a normalized Gaussian. So original Gaussian was 1, written as an integral. If I integrate over this thing, this will also be 1. The only difference is that I have a plus here, so integrating over, it looks worrisome, but Fourier transform will work. This covariance have migrated into the numerator from having been in denominator. But the main thing is that Fourier transform of a Gaussian is a Gaussian.